Hey, it's Bill Trombley from Trombley Tool in East Troy, Wisconsin. Today this will probably be a relatively short video. Today it's about tool quality. What does that mean? Is it the quality of the equipment? Yeah, to a certain extent. But this is a little bit more, even more basic than that. So what this basic discussion would be about is things like hammer quality. And some people may look at that and go, where are you going with this? Does a hammer matter? It does. This is a Blue Point hammer that I bought from a friend of mine, Robert, who restores body hammers. He's a great guy. This one, he had it, he restored it, and it became quickly my favorite hammer. Lightweight, small head, small diameter face. A lot of what Ken Sakamoto, who is an excellent metal shaper or a metal finisher, talks about as far as quality of hammers, all exists in this as far as weight and size and everything else. When I first started out, I bought a Harbor Freight body hammer, and every time you would use it, you'd put dents in the face. And that's kind of what this is about when we talk about quality of tools. So if you look at this face here, Robert polished it, and then I maintain the polish on it. For the most part, it stays shiny all the time. But here's my ball peen hammer. This is actually my great uncle's ball peen hammer that I inherited. It's probably pre-World War II. This thing gets used every day, but we're not using it for body or metal shaping. We're not using it for metal finishing. So look at the quality of the face. They're pretty darn beat up. The Harbor Freight tool, you would use it, no matter how you go about polishing it, because it was so soft, it would quickly mark up. And it causes a big problem, is it prints in the metal. And so the quality of your surface finish is only as good as the die face. So if you see this piece here, that's fingerprinting to a certain extent on there, and the oil process. Look how shiny it is. That is directly out of the planishing hammer. That's not any other process applied to it. It's not polished, it's not Scotch-Brighted, it's nothing. Look at all the shrinking that occurred in this whole panel on this side. Yeah, look at the quality of the finish. There too, and even on the inside. This is directly out of the equipment. There's no handwork that's going into this. And that's because of tuning and cleaning up the dies. Very important. You don't see a lot of people take it to a high level. If you saw, how many times have you guys had body dollies, or go over to a friend's shop and get their body dolly, and it looks like this? Look at all the marking in it. Surfaces that aren't flat. Does it matter? Well, if I'm hammering on this and this is printing into the surface, my part will only be as flat as the surface. And you may look at it and go, well, that's close enough. Well, if you're going to make high quality metal finish components like what Ken Sakamoto does, it matters a lot. When I was out by Ken, what we did was we took body dollies out there, and he had us spend the day of block sanding these and straightening out all the highs and lows, all of the lumps in it, and then polishing them. Now this is my favorite dolly right here, track dolly like that. This is a Blue Point one, I think. Thought it said it on it. And super high quality steel, but we cleaned up all the surfaces. Now you might not believe it, but put a little bit of Sharpie on it and block sand your dollies. you'll be amazed at how poor the quality of the surface is. And picture it. These things are forged. Well, it's a guy sitting in a grind room that is belt sanding these things to clean them up, and maybe a light buff. He's not trying to get any of the highs and lows out. He doesn't even know it or care. So you're going to have to clean up your tools. I do the same thing with body hammers. Robert cleaned up this one, but even before I got this, every single body hammer that I've had, I've fixed and polished them up and trued up the die faces. So very important. Give you another example. As you guys know, I have my CP planishing hammer here. This is a 24-inch floor model CP. This here, originally when I got it, it came with one upper die, this one, and then I machined up a series of upper dies that were soft. It was just quick, get the machine going, right? Got the machine, I want to get it running, I don't want to wait for a shipment of dies to come in, grab a piece of bar stock, machine it, and go. And they were soft, they weren't heat treated, they were flat, and they worked okay. I went out and I bought a set of aftermarket CP upper dies, and they looked great until I started using them, and I could never get a consistent, clean looking surface finish. No matter how well the die face was polished, it had an issue with it. And I'll actually, because I've now fixed these dies, it'd be hard to show, but you could see here in this die, if I get the light right, see the air gap that let's see if I go against my shirt. Well, you'd have to trust me, right about there. The center's dished out. Even on the brand new dies, they're not flat. The upper die needs to be flat. I took these, and because they're heat treated, I surface ground the dies and made them flat so that when you would hold this up, you could see no air gap. And in doing so, look at what it did to the surface finish, the quality of the finish. And that's just directly out of this machine. Same thing with the lower dies. This here is a hammer and dolly just on steroids. This is a hammer and dolly that hits at 3,200 hits per minute or whatever this runs at. Same thing with my power hammer in the back. As you guys know, I've made all of the dies that are in this machine here. All my uppers and all the lowers. Well, all of these dies, I've ground them and polished them. And it makes it so that when I produce parts, you get a high quality surface finish every single time. This piece here is a retainer for a landing light. The original one was cracked. It's for a Cessna 182, and you can see the cracks here in this corner and on that corner, like that. And you can see I tack welded it in the corner. And what those tack welds was just to hold the geometry. It's 2024 aluminum that's considered to be non-weldable. And we've talked about, I think, some of this in the past. Can you weld 2024? Absolutely. I can weld 2024 beautifully. Does it crack? And people go, well, the weld will crack. Actually, it's not the weld that'll crack. The issue that'll happen is it'll crack alongside the weld. And it's due to vibration, and it's actual heat destruction of the material itself. The welding temperature is so high that it actually alters the grain structure of 2024 internally and will cause it to become weak. So in our documents, AC 4313, which we use for aircraft repair, it's deemed to not even be acceptable to weld. You know, even though I can weld it and make a beautiful looking weld, it's not recommended because of the material grade. So I had no choice but to remake the part. So kind of getting off the beaten path, but the reason why I gotta explain it is there could be airplane guys watching this going, oh my God, you welded that. It's just a tack weld. That's why we made it new. So, but here too, you can see the quality of the component. And this too is directly out of the planishing hammer, out of my CP planishing hammer that I use to stretch this here with a linear stretch die. And then I use plastic no-bar dies in my Eckhold machine, which is that machine right there, to do the shrinking, to eliminate tool marking. And it's so little, you might be able to see it maybe right there. That's from the Eckhold marks. It's hard to even see. But quality of the tool is important. So you want to clean up your body dollies and your hammers. You may go, well, I don't care because I'm going to DA it and sand it. Okay. But in the past, we had talked about that if you had a localized high spot in your tool and it prints really hard, you'll actually put a lot of stress into the panel. And it's true. And people look at that and go, well, I don't see how that matters. Well, this piece of aluminum is only 40 thousandths thick. If I put a hammer blow and I just hit this hard, I've changed that structure of the material grade right where the hammer blow is. It's created a hard spot. Now picture if I have a hammer face that isn't a quality face, and my hammer face looks more like this ball peen. Think of all of those individual hammer blows I could easily put in the part. Each time I do that, that's a hard spot. That's causing stress. Same thing in a planishing hammer, same thing in a power hammer, same thing with poor quality dies in an English wheel. And that stress is what makes it so that you see panels that lock up, where all of a sudden people are going, I got to go to anneal it. It makes a difference. And people don't believe me, but look at shapers that are producing high quality parts. Look at the surface finish of their parts. They're all high quality surface finish parts. Look at the stress in the parts, virtually non-existent. Ask those guys, how often do you anneal? Seldom, if ever. It does make a difference. When I had met Peter Tomasini, he had said one of the most important things was building a panel that all four corners of the panel touch the floor or touch the table. Look at this air intake. All four corners touch the table. There's no stress in this. This is not hard in any way. And this material here is 2024 O by 40 thousandths. Same thing as this. They'll be heat treated to a T4 condition, which I'll do in-house. This part here is in mid-process. And what it actually is for is this Cessna 182 cowling here. And that piece is this air scoop right in here in the center. Making that piece new. And the reason for making it new is the air box. The air filter had actually rubbed through right here. There's a big air cleaner that mounts in this opening. Yeah, it mounts right there, and you can see where it rubbed through. So, can't do a weld, and I could rivet on a patch, but I elected to just make it new. And actually, that landing light retainer goes in this hole here. So, but the point is look at the surface finish and the quality of the component, and there's no stress in it. You know, all four corners of the panel touch the table at all times. This thing isn't yielding and all this stuff and these weird problems. Guys that are new to metal shaping, and I'm guilty of this all. You know, in the beginning you'd build panels and it'd have so much stress in it. You know, I always said I could make a piece of aluminum seem like it's a piece of armored plate, because they could make the aluminum so hard from the metal shaping process, and had so much stress in it that it would never lay flat or true because of the shaping process. So refining your shaping process, polishing your tools makes a difference. One thing to do to help keep them polished, I use Johnson's paste wax, and you guys have seen this stuff before as my mold release. The benefit is that it's easy to apply, and it does make it so that they stay rust free, especially with the humidity that might exist in the shop here in the summertime. So thought it might be a simple, quick video. We got a lot that's going on in the shop. We've been doing a lot of machining and engine work and non-metal shaping projects. The gas tanks for the 1931 Travel Air are almost wrapped up. We're going to be welding those together here shortly. And after that, we got some wheel pants that we're building for a Blanca, which are pretty cool. I got a car project in the shop that I can't show, which is really phenomenal. And after that, we got some other wheel pants that are coming. Some World War II fighter plane parts. So a lot going on, and a lot more to come. So we're just kind of in a lull at the moment. So thanks for watching. If you got any questions, post them down below. Like, subscribe, tell all your friends, and thanks. Bye.